Hello, this is Mrs. Ross, and this is Lesson 87 Practice Set and Starred Problems. Let's go ahead and get started. So today we're going to talk about multiplying algebraic expressions. It's called multiplying algebraic expressions. And until you completely 100%, this is something you can do in your sleep. It is advisable, meaning I suggest strongly that you write out every single step. Okay, so let's get started. It says negative 3x times negative 2xy, and we know this is times because there's no operator between the two. So we're going to multiply our numbers, and then we're going to multiply our variables. So let's go ahead and multiply our numbers. A negative 3 times a negative 2 gives me a positive 6. And then when we multiply these, you can see I have an x from the 3x, an x from the 2xy, and a y from the 2xy. These have the invisible 1 as their exponent. And we know that when we multiply something with the same base, we add the exponents, correct? So this is going to be x squared, and then the y just continues, and that is our answer. Okay? Keep in mind, we're not solving. We can't solve any of this because they haven't told us what x and y are. We are merely simplifying. So let me change my ink color, and here is b. So we'll have b comes over here. And I have 3x squared times xy to the 3. So here, I'm multiplying 3 times 1 because there's an invisible 1 in front of each of these, right? And then I have x squared times x to the 1 times y to the 3. Okay, so 3 times 1 is 3. And then I'm going to add my exponents here. X to the 2 plus 1 is x cubed, y cubed, and that's my answer. Okay, let's change colors. And let's do C. We'll do that here in the middle. So I have 2a squared times negative 3ab cubed. I'm going to multiply my numbers. And then I have a squared times a times b cubed. So 2 times negative 3 is negative 6. I have a squared. This has the invisible 1 as its exponent. So I have a to the 2 plus 1, which is a cubed, b cubed. So that's the answer there. And the last question we have here is D. D is negative 4x times negative 5x squared y. Let's multiply our numbers. X times x squared plus y. Okay, so negative 4 times negative 5 is a positive 20. And then we know this is x to the 1, so we're going to add our exponents. And then y just kind of hangs out. So that's how we multiply algebraic expressions. Okay. It says find each product by multiplying the numerical factors and then gathering. Okay, same thing. They've just added another thing here. So, oh boy. Okay, so we have negative 1, we have positive 1, and we have 2. And then for our variables, we have x to the 1 times x to the 1. And you can see I'm lumping together or grouping my x's and then grouping my y's. So then y squared times y to the 1 times y to the 1. Okay, so let's go ahead and multiply this out. This is negative 1 times 1 is negative 1. Negative 1 times 2 is negative 2. Okay, and then we have our x to the 1 plus 1, which is x squared. And then we have y to the 2 plus 1, which is y to the 4th. Okay. All right. I may have to erase at some point, but let me do F over here. So I have negative 3 times negative 2 times 1 times m to the 1, m to the 1, m to the 2, that's all my m's, times, oops, n to the 1 times n to the 1. All right. So I have negative 3 times negative 2, which is positive 6. And then I have m, 1 plus 1 plus 2, which is m to the 4th. and then I have n squared, n to the 1 plus 1. So this is my answer to F. Let's change colors. Let's do G. So I have 4 times 3 times negative 1 times 1. You see the negative 1 right here? Yeah, it's invisible. And then I have W to the 1 times W to the 1 times W squared times, okay, Y, oops, to the 1, Y to the 1 times Y to the 1. So that takes care of, I've got all of my W's taken care of, I've got my Y's taken care of. Now I need to do my X's. X to the 1 times X squared. Okay, so let's do our numbers first. 4 times 3 is 12, times negative 1 is negative 12. Let's take care of our W's. 1 plus 1 plus 2, which gives me W to the 4th. Y, 1 plus 1, Y squared. X1 plus 2, X cubed. So there is my answer. And I'm going to have to go ahead and erase, I think, the first one that we did, so that we can get some room to do H. You can see these problems take a little bit of room, a little bit of time, a little bit of effort. Let's see. Okay. Did I click it? Oh, good. Okay. All right, so we're going to take H up here, and let's get our numbers. So we have 5 times negative 2 times negative 3. Those are all of the numbers that I have. Now let's take a D. So I have D to the 1, and I'm going to cross it out as I go so I don't forget what I've done. Times D to the 1, I'm going to cross that out. So I've already done that, and that, and that. And then D to the 2 times D squared. Cross that out, and then I have F. So I have F to the 1 times F to the 1. That takes care of that one, and then I have G, which is just hanging out. Let's do our numbers. So 5 times negative 2 is negative 10, times negative 3 is positive 30. And then I have D, D to the 1 plus 1 plus 2, which is D to the 4th. I have F to the 1 plus 1, which is F squared, and then G just kind of hangs out. Okay. Let's see. I show 2 methods to do this, so I'm going to have to do some erasing. Hopefully you've written this down already so that this doesn't drive you crazy. You can always pause these videos if you need to. Okay, so the first way of doing this is 3xy cubed squared. When you have parentheses and an exponent, you pretty much can square everything inside. So this is going to be 3 squared x squared y cubed squared, which is 9 x squared, and then when you have an exponent to an exponent, you actually multiply them, so that's to the 6th. The second way of doing this is to break it out, because this is 3xy cubed squared, and then do it like we've been doing all the rest of them. 3 times 3, and that takes care of that. X times x, that takes care of that. Y cubed times y cubed. Okay, so 3 times 3 is 9. This is x to the 1 plus 1, which is squared. This is y to the 3 plus 3, which is to the 6th. All right. It says graph the whole numbers that are less than or equal to 5. So this is 5. Whole numbers that are less than or equal to 5, which means each one of these dots. You see it's not a highlight. I have to do each one individually because it's whole numbers. For each measure of the circle, use this for pi. For circumference, I always write the formula first. And area. So r is equal to 40. I'm sorry, 70. Circumference, we're going to use this. So this is 2 over 1 times 22 over 7 times 70 over 1. I can reduce this. So I have 2 times 22 times 10 over 1 times 1 times 1, which is 440 millimeters. Okay, I'm going to change. And then here I have 22 over 7 times 70 squared. So 70 squared is, I believe it's 490, no, 49, 4,000. Okay, this is why we don't do math in our heads, because the coffee is not merely strong enough. Okay. Where are we? Okay. Okay, so 7 will go into that 700 times. So I have 22 times 700. Which is, I got, this is a super ugly number. I may have done something wrong. You guys can tell me. Ratio boxes. The sale price is $24 for a game board that was 80% of the regular, what was the regular price. So when I did this one in the last video, what I did was I said, okay, so 80% or 80 per 100 is equal to 24 over whatever the total is. And I just wrote it this way. So then we cross multiply, divide, and that is $30. Okay, let's change our color. David had finished 60% of the race, but he still had 2,000 meters to run. How long was the race? Let's go ahead and use our ratio box for this. And we are going to need a total, percent, actual. So he'd finished, still had. So he'd finished 60% of the race. So we know 60 plus 40 is 100. He still had 2,000 meters to go. And then we want to know what the total is. So this shows us what our proportion is going to be. And we cross multiply. 1, 2, 3, 4, 5. That's a lot of zeros. I think he had 5,000 meters left. Yay. Oh, mercy. Find the area of this figure. Corners that look square are square. That's delightful. What's the best way to do this? It's ugly. I wonder if I should take area 1, and then this whole thing will be area 2, and then I'll subtract out area 3. I hope that that's not confusing. So what I'm going to have to do is I'm going to have to do area 2 minus area 3, and then I'm going to have to add area 1 to that to get the total area. Sorry, so area 1 is length times width, which is going to be 8 times 4, which is 32. And then area 2, which is the whole rectangle, is 8 by, let's see, 6 plus 4. So 8 times 10, which is 80. Then area 3 is the area of a triangle, which is 1/2 base times height. The base of this triangle, let's see, if this is 10, and that's 8, that's 2. So this is going to be 6. And then the height, let's see, so we have 4, and that's 4, so it's also going to be 6, because that's 4, and this is 2. Okay, so 1/2, 6 times 6, 1/2 of 36 is 18. So we'll take 80 minus 18, which is equal to